One of the common results of interest is the model's factor of safety. This is a number that indicates how well the part is performed in reference to the strength of the material it's made of. In this case, we saw that the part didn't yield under the load it experienced, but by how much? When you design a component, you typically design it so that it's stronger than it needs to be. For instance, if you're designing a bracket to hold a shelf, and you expect the shelf to be able to hold 25 pounds, you might over-design it so that it holds 100 pounds without failing. Over-engineering provides a higher level of confidence in a design to account for certain unknowns, such as potential imperfections introduced in the manufacturing process, material degradation over time, and uncertainty in load estimates. Factor of safety is typically a value you target as a designer, and depends on many of these unknowns as well as other considerations, such as the consequences of your part failing, and the material and manufacturing costs associated with over-engineering. The appropriate factor of safety for your design will depend on the intended use of the part. Continuing with our bracket example, if I know the expected load on the shelf will be 25 pounds, but I want the shelf to safely be able to hold up to 50 pounds, then I would be targeting a factor of safety of 2. You can see that by dividing the designed maximum load of 50 pounds by the maximum expected load of 25 pounds, we arrive at the target factor of safety of 2. You should also see that if I design the bracket to hold exactly 25 pounds, the factor of safety would be 1. Back now to the results in Express. You see that this part has resulted in a factor of safety of over 4.5. Another way of saying this is that the part's yield strength is about 4.5 times higher than the maximum stress it experienced under load. In this case, the part does not fail under the 4,000 Newton load we've applied, since the factor of safety is well over 1, but it's still up to you as a designer to know what the appropriate factor of safety should be. Now for this example, I would like to target a factor of safety of 5. To see the areas on the model with a factor of safety below 5, I'll type in 5 and click the Show Me arrow in the task pane. Areas shown in blue have a factor of safety over 5 and are very safe. Areas shown in red have a factor of safety less than 5. The FOS calculation in Express compares the von Mises stress in your part to the yield strength of the material assigned. This is the most common method for evaluating strength in ductile materials, as I mentioned earlier. In the full versions of SOLIDWORKS simulation, factor of safety can be calculated for ductile materials using the Tresca, or maximum shear stress criteria as well. Brittle materials can be evaluated using the Mohr-Coulomb criteria, as well as the maximum normal stress criteria. The help documentation in SOLIDWORKS describes each of these in more detail.